so we are continuing simplifying expressions with rational or fractional exponents. And so this brings us to 27b. We did 27a in the previous video. So we have 25 to the negative 3 over 2. We're trying to simplify that. Recall, and now we can use this for we only did integer exponents before, but we can, nothing says we can't use rational exponents. So remember when we had a before a to the negative n, recall a to the negative n, when we studied exponent, recall a to the negative n is just equal to 1 over a to the n, right? Well, the same thing, we're going to apply the same principle. So 25 to the negative 3 over 2 is just going to be 1 over 25 to the 3 over 2. In this case, don't forget, the 3 is going to be the power or the exponent, and 2 in the denominator here is going to be the root, right? Called the root or the radical, right? So the root here. And so what we have here is just going to be 1 over, the root is 2, so that becomes square root, and 1 over square root of 25, and the exponent is going to be 3. So that's just 1 over, what's the square root of 25? The square root of 25, again, this invisible 2 here, you know, I put it there anyway. The square root of 25 is just going to be 5. I'm saying 5, but I'm writing 2. It's actually 5, yes. Square root of 25 is 5 raised to the 3rd power. So then the answer comes out to be 1 over 125. Okay? Alright, so please watch this video again to have it make more sense to you, alright? Alright, so we continue. So now I want to look at some more. So if you have, it's 27c, if you have x to the 2/7 times x to the 4/7, well, you're still going to use exponent laws. What exponent laws say? Exponent laws say that you add the exponents when the bases are the same. Alright? So again, remember, x to the n times x to the p would just be x to the n plus p. So you're using this principle right here. So, well, if that's the case, you go back to this. This is just going to be x to the n plus p is just going to be 2/7 plus 4/7, which is just going to be x to the 6/7, which you can write as that, or you can just rewrite it as the 7th root of x to the 6, okay? So these two answers are equivalent. Most people might prefer this. It all depends. Alright? And we will also look on D. So 27 part D. 27 part D says have 64 x to the 6th y cubed, and I want to take 1/2. So I'm going to use what we did before. We're going to use the same thing. We're going to use the distributive property of exponents, right? You're going to multiply all the exponents by 1/2, right? So that's just going to give me now 64 is an invisible 1 here, so it's going to be 64 to the 1/2 x to the 6 times 1/2 is going to be 6 times 1/2, or let me just, so it's going to be 6 times 1/2, just write that, and then x to the 3 times a half, right? Just keep it simple. And now that's going to be we know that anything to the half power is the same as the square root. So that's the square root of 64, right? Times, on the outside here, x to the 6 over 2 times x to the, not x rather, sorry guys, this was supposed to be a y here, go back up to the y, times y to the 3 over 2. And finally, the square root of 64 is 8. This is just going to be x cubed. And now this, you can write it as the square root, so 2 there, of y cubed. So you can write it like that. Okay, we like to have prefer radical in our answers to when possible, right? So that's what we have. Incidentally, you could have written this as 8x cubed y. Leave it like y to the 3 over 2 if you want. Alright, but this might be preferred.